students, in this video also we will solve some examples on greatest integer function and later on we will go for next topic. Example: how many zeros would be there at the end of 100 factorial of 500 factorial and of 1000 factorial. Solution: let n equal to 100. Let's solve for 100 factorial first. To find the zeros at the end of 100 factorial, that is, it is enough to find the highest power of 10 dividing 100 factorial. These are two equivalent things. So here 10 is equal to 2 into 5 and 2 and 5 are relatively prime. Okay. Let E1 be the highest power of 2 dividing 100 factorial and E2 be the highest power of 5 dividing 100 factorial. Then the highest power of 10 dividing 100 factorial is E equal to minimum of E1, E2. Now therefore E1 is what? Summation I from 1 to infinity 100 upon 2 raised to I. This one. So here 100 upon 2, that will be 50. 100 upon 2 square, that will be 25. 100 upon 2 cube, it will be 25 by 2. So it will be 12. Then 100 upon 2 raised to 4, it will be 12 by 2, so 6. 100 upon 2 raised to 5, greatest integer function, so 6 by 2 will be 3. Then 100 upon 2 raised to 6, that will be 3 by 2, so it will be 1. And 100 upon 2 raised to 7, it will be 1 by 2, that is its greatest integer function is 0. Therefore E1 equal to 50 plus 25 plus 12 plus 6 plus 3 plus 1 plus 0, that is equal to 97. And E2 is summation I from 1 to infinity 100 upon 5 raised to I. So here 100 upon 5, that will be 20. 100 upon 5 square, that will be 4. 100 upon 5 cube, that will be 4 by 5, so 0. Therefore E2 is equal to 20 plus 4 plus 0, that will be 24. Hence E is equal to minimum of what? 97 and 24, and that will be 24. That will be 24. So this implies 24 is the highest power of 10 dividing 100 factorial. That is 10 raised to 24 divides 100 factorial, but 10 raised to 25 doesn't divide 100 factorial. This implies there could be 24 zeros at the end of 100 factorial. There could be 24 zeros at the end of 100 factorial. Now similarly, let's solve for 500 factorial and for 1000 factorial. Okay. So let n equal to 500. Now to find number of zeros, occurs at the end of 500 factorial, it is enough to show that highest power of 10 dividing 500 factorial. So here 10 is equal to 5 into 2, and the GCD of 5 and 2 is 1. Therefore, highest power of 5 dividing 500 factorial is E1, and that is equal to summation I goes from 1 to infinity 500 divided by 5 raised to I. Okay. So 500 upon 5 raised to 1, that is 5, it is 100. 500 upon 5 square, that is 25, so it will be 20. 500 upon 5 cube, that will be 4. 500 upon 5 raised to 4, that will be 0. Therefore, E1 is equal to 100 plus 20 plus 4 plus 0, that is 124, and highest power of 2 dividing 500 factorial is e2, that is summation I goes from 1 to infinity 500 upon 2 raised to I. 2 raised to I. So here 500 upon 2, it will be 250. 500 upon 2 square, it will be 125. 500 upon 2 cube, it will be 62. 500 upon 2 raised to 4, it will be 62 by 2, it will be 31. 500 upon 2 raised to 5, so 31 by 2, so it will be 15. 500 upon 2 raised to 6, so 15 by 2, so it will be 7. 500 upon 2 raised to 7, that will be 7 by 2, so 3. 500 upon 2 raised to 8, it will be 3 by 2, so 1. Therefore, E2 is equal to, next one obviously 0, for the all are 0, that's why we will stop here, okay. So 0. So E2 will be what? 250 plus 125 plus 62 plus 31 plus 15 plus 7 plus 3 plus 1 plus 0, and that sum is 494. Now from here we get thus the highest power of 10 dividing 500 factorial is E equal to minimum of E1, E2. That is E equal to minimum of 124 and 494, and that is nothing but 124. Therefore, 10 raised to 124 divides 500 factorial, but 10 raised to 125 doesn't divide 500 factorial. Therefore, 124 zeros occurs be there at the end of 500 factorial. Okay. Now the next one, let n equal to 1000. To find number of zeros at the end of 1000 factorial, it is enough to show that highest power of 10 dividing 1000 factorial. So here 10 is equal to 5 into 2, and 5 and 2 are relatively prime. The highest power of dividing 1000 factorial is even, and that is summation I from 1 to infinity 1000 upon 5 raised to I. So here 1000 upon 5, that will be 200. 1000 upon 5 square, it will be 40. 1000 upon 5 cube, it will be 8. 1000 upon 5 raised to 4, that will be 1. 1000 upon 5 raised to 5, it will be 0. Therefore, E1 is equal to 200 plus 40 plus 8 plus 1 plus 0, so it is 249. And the highest power of 2 dividing 1000 factorial is E2, that is summation I from 1 to infinity 1000 upon 2 raised to I. So here 1000 upon 2, so it will be 500. 1000 upon 2 square, so it will be 250. 1000 upon 2 cube, so it will be 125. Next 1000 upon 2 raised to 4, so it is 62. Next 1000 upon 2 raised to 5, so it is 31. 1000 upon 2 raised to 6, so it will be 15. Next 1000 upon 2 raised to 7, so it will be 7. 1000 upon 2 raised to 8, that will be 3. 1000 upon 2 raised to 9, it will be 1. And 1000 upon 2 raised to 10, that will be what? 0. Okay. Therefore, E2 equal to 500 plus 250 plus 125 plus 62 plus 31 plus 15 plus 7 plus 3 plus 1 plus 0. So it is 994. Now, hence, the highest power of 10 dividing 1000 factorial is E equal to minimum of E1 E2, that is minimum of E1 is 249 and E2 is 994. So E is 249. Therefore 249 is the highest power of 10 dividing 1000 factorial. That is 10 raised to 249 divides 1000 factorial. But 10 raised to 250 doesn't divide 1000 factorial. Hence 249 zeros occurs at the end of 1000 factorial. Okay, so as such these examples will be solved. Now here our first function, that is greatest integer function, is over. Here at last let me give one example as a homework to you, and here we will stop for this video. In next video we will start the next function, that is arithmetic function, arithmetic or number theoretic functions. Okay, so now before stop we will let me give one example as a homework to you. Try to solve that. Okay, so here find, or what is, example, this is for homework. What is the highest power? What is the highest power of 70 which divides 533 factorial? 70 I am giving, okay, which divides 533 factorial. Now you know 70 can be written as 2 into 5 into 7. This is a hint. So you have to find the highest power of 2 divides 533 factorial, highest power of 5 divides 533 factorial, highest power of 7 divides 533 factorial, and take minimum of them. Okay, thank you.